Okay, thank you, Tina. Can you see my screen now? I think I'm starting. Yeah,
yep, I can see it.
Okay, so in this talk we are going to explore the innovations that we develop in the ONEedge project. In the project we follow an agile model for executing the project, which is divided in 3 cycles. In each cycles we perform all the development along with or together with the dissemination, exploitation, and validation activities, so we can really react quickly to new demands of the users that are trying the technology or the new innovations that we identify in the ecosystem of the cloud edge market. In this talk, I'm going to describe each of the innovations that we did or the main innovations that we did in each of the cycles of the project, and we are going to review how we deliver these innovations to the users, and how you can try all the developments that we did during the project. I would say that the one of the main innovations on the project is the architecture of itself of the ONEedge project. In the ONEedge project, we build a distributed layer on top of distributed resources across the clouds, edge locations, or even your on-premise data center, to give you an abstraction of this infrastructure, so you can easily deploy edge applications or across this edge cloud continuum, right? I would say that the main 3 components of this architecture is, the first thing, the application model. So you can define the application, which is composed of multiple VMs with specific requirements in terms of capacity, networking, and storage, for example. So you define your application of a composition of these VMs, so that are going to, or containers that are going to host the functionality of your application. That can be either your application itself, or can be, for example, like a Kubernetes cluster where you are going to deploy a Kubernetes or cloud native application. These applications run on a distributed cloud infrastructure, which is composed of edge clusters. An edge cluster is a subset of storage, networking, and compute resources that are created on demand on different locations in terms of your requirements for deploying the application, or for example, close to users in order to reduce the latency, or considering the cost, or even for security reasons in your own data centers. And these edge clusters are integrated with first an edge provider catalog, so you can really use multiple cloud providers or edge providers in a transparent way. And it's also integrated with an application or popular application marketplaces, so you can easily consume or deploy applications that already exist in marketplaces. For example, Docker Hub and Docker-like registers and so on. So when we started the project in the first cycle, the first thing we wanted to tackle was the integration with micro VMs, hypervisors, or virtual machine managers. We integrated Amazon Firecracker, which is a lightweight micro VM hypervisor based in KVM. So the idea is that we assume that edge locations may require more lightweight approaches to create your virtual applications. So Firecracker seems to be a good fit for this, and we implemented support for managing Firecracker VMs in OpenNebula. Also, we integrated all of this with the Docker Hub, so it's really easy and simple to wrap a Docker Hub image with an application and run that in a Firecracker, for example, container or VM. And the other challenge that we faced during this first cycle was improving and de-monitoring subsystem. So considering all these highly distributed application, we improved the scalability of the system by streamlining the monitoring messages, by securing the monitoring messages, and all this monitoring traffic and subsystem really handles this distributed infrastructure. Along with that, we added some improvements to Sandstone, networking in VMware, and the composition of applications, which in OpenNebula is implemented through the OpenNebula OneFlow component. All of these innovations were delivered through the OpenNebula 5.12 framework release, and you can access to all the details of the implementation architecture and the software we produced through the ONEedgeIO webpage, where all this is publicly available, so you can check the deliverables and the reports, and even you can find links to grab and try the software. The next cycle, we concentrated on creating this edge infrastructure. So we defined the edge cluster itself. I'll say that I think we believe this is a really important innovation of the project, because it orchestrates three main pillars in order to create the cluster. The first one is the provision of the resources itself, that is using Terraform in our case. Then the configuration of the edge clusters, which we are using Ansible for this, and the cloud management system which we are using OpenNebula. So these three pillars are effectively orchestrated: the provision, configuration, and workload management, in order to create these edge clusters in a distributed way. For the edge cluster itself, we develop a specific solutions, for example, to optimize the transfers of application images, or even to networking. So we can create overlays on cloud providers that have different or very different application or networking models. All of these edge cluster architecture were delivered as a provider catalog. So we define how an edge cluster will look like in each provider, based on different Terraform templates or specific Ansible roles, and specific configuration files or specific networking drivers. So each provider can implement an edge cluster. So we have integrations with Amazon, Equinix, DigitalOcean, Google Cloud, or even Vultr. And we receive a lot of requests for deploying Kubernetes workloads on the edge. So we revamp our marketplace to deploy CNF certified Kubernetes clusters. So we have Kubernetes appliances that can run on top of these edge clusters, or you can run your Kubernetes or cloud native applications. And also have K3s, which is a lightweight version of Kubernetes that we think that is really well suited for the edge. In this second cycle, we created this FireEdge web UI, which is a single plane for managing all your infrastructure, where you can go to a web UI and easily define where you want your edge clusters, what capacity, which providers you want to use, and all the deployment of the cluster is done automatically. Finally, we incorporated some basic features like backups for your VMs or marketplaces, and again some more improvements in the OneFlow component. All of this were delivered through the OpenNebula 6.0 Montero release. So you can create and see and test all these innovations and improvements since OpenNebula 6.0. Again, all the architecture, documentation, design documents are available and public online. So if you want to go and check them, I put the links in the slides, and you have all the information in the ONEedge web page. In the sales cycle, we focus on delivering all of these software as a service. So we define the basic service in terms of requirements and security, and we follow a GitOps approach. So we have a Git repository that represents an edge instance, and we are able to create new edge as a service instances. So you can easily access this software to create your infrastructure as a service. So we create a simple way based on creating GitHub issues, and that will trigger the creation of an edge as a service instance that can be tried for users in order to test the technology and to create the edge infrastructure. We further integrate this cloud provider marketplace. So we open the marketplace to any other provider that want to develop their own drivers for ONEedge. So this means that we standardize the definition of an edge cluster. We standardize the interfaces, so it's easy to add new networking drivers or networking implementation for the edge clusters and so on. And also we improve the Kubernetes integration. We add the ability to have load balancers and also working on the networking implementations of the Kubernetes appliances. Finally, we find out that there are also several requests for using ARM devices at the edge location, because those devices are found in multiple edge locations. So we prepare OpenNebula to build ARM packages and being able to deploy these clusters on ARM-based devices. Again, all of this was released in OpenNebula Red Square 6.2, and which is our latest stable release, and all of this can be accessed or tried through this release. Again, all of this is available at the web page. And yeah, the end cycle. In this last part of the project, we concentrated on streamline the Edgeify solution. So it's like a consolidation of the project where we improve this edge as a service concept that we developed in the previous cycle. We were very lucky to have several users that were trying the edge as a service and Edgeify product and provide us with some feedback. So, for example, we find out that people wanted to use their own data centers, and they have like different VPN requirements, and we needed to integrate those services. At the beginning, we thought only for a subset of the OpenNebula services, and we needed to extend that. So we added different extensions based on this feedback. We didn't consider this initially, but we are going to deliver these software additions as a technical analyst to the latest delivery of the project. And thank you for your attention. That's it. As I said, all this information and software is publicly available and can be accessed through the ONEedge page.